Hello, this video serves as our ME110 product case study. Our group consists of Brandon, Van, Victor, and Jason. The product that will be analyzed is an airless paint sprayer.
The case study will begin with the outer shell, motor dust cover, and the supporting frame of the sprayer, which is made of injection molded plastic. We know this because of the ejector pin marks that are present on the pieces, which are left when the ejector pin pushes the part out of the mold. In addition, there are also visible flash marks left by the parting line of the mold. Advantages of injection molding include good dimensional accuracy, high production output rates, and little waste, while being able to produce thin-walled pieces. The disadvantages of injection molding include high startup cost and extra work needed to design parts specifically for injection molding.
Next are the two aluminum components that mount to the electric motor and the paint pump assembly. Viewing the components, it was determined that they were manufactured in a two-part sand casting. Evidence of this can be seen with a ridge that runs along the length of the parts where the seam of the two halves of the casting met, along with the part's rough surface finish and complex geometry. Post-process machining can be seen by the smooth and shiny surface finish along the mating surfaces, bolt holes, and internal threads. Feature orientation and location are both important tolerance concerns for these parts to ensure that the bolt holes line up to allow for proper assembly. In addition to the size tolerance of the counter bore to ensure a snug press fit of the pump assembly bearing into the cast aluminum housing. An alternative way to manufacture the same components could be done with CNC machining of billet aluminum. However, the machining time to achieve parts with complex external and internal geometries will take longer and waste more material, resulting in higher manufacturing costs and lower production rates.
Gears which function as crank in the reciprocating pump are made of carbon steel and formed by milling and hobbing. They were recognized by its high strength and accuracy of the gear teeth. Then these external gears are finished by grinding process to increase accuracy. Alternatives can be casting or gear generating using pinion-shaped cutter, but it has lower dimensional accuracy, rougher surface finish, and lower production rates. Here's the bearing which transmits reciprocating force from the motor and gears to the piston rod. The bearing rings are made of carbon steel and manufactured by forging, turning, grinding, and other finishing processes. They have high strain and rough surface finish. A socket bore head is attached to the outer ring of the bearing by welding and grinding. These are the rods used as shafts in the pump that are made of alloy steel with high strain and density. It's created by hot rolling, cutting, turning, and chamfering. In both machining process, the head of the piston rod is drilled to make a hole for the ball socket joint. The rods are then go through the grinding, polishing, and chrome plating processes for an excellent surface finish so that it can move smoothly. Feature form, size, and orientation of the piston rod are also controlled very well here. That importantly ensures the proper assembly process and airtight interface between the piston rod and cylinder. Alternative manufacturing process can be forging and facing, but they have higher tuning costs and worse surface finish.